Breaking the wall of CNT transistors. AlHaitham AlKalbani, Falling Walls Lab, Oman.
Good evening. Let's start with something we have all experienced before. Phones overheating. Or, for example, your battery drains very quickly on your laptops. This happens due to a very important component in our equipment called the transistors. So transistors has been powered from the last 60 years through the silicon transistors. Silicon transistors are basically controllers that switch on and off the current inside the chips, inside our devices. So they have been powering phones to supercomputers. However, through the big demand on the industry of shrinking these devices and the chips industry, silicon transistors face different of issues. As we shrink these devices or transistors, the current inside them, they drain through the terminals. And this will result in different issues, such as scaling limitations, also high leakage of current, limited electric constants, or even poor performance at higher frequencies. So such a series of problems. Take an example. For example, Apple, they spend around $500 billion every year in the R&D of the silicon chips. While Intel, for example, they spend around $5 billion every year just to mitigate these chips. So the wall is clear. Silicon transistors has reached its physical and quantum limits. And these limits affects the companies and the users by itself. So in order to break that wall, we will introduce a new material called carbon nanotubes. So carbon nanotubes are carbon atoms that rolled on sheets, and they have different advantages. They have higher electrical and thermal conductivity. They're stronger than steel. They have excellent flex properties, so they transform these currents very quickly. How we do that? With a lot of numbers. Quantum mechanics. I had a lot of breakdowns until I got this one down, but I used the non-equilibrium green function that tells me how to deliver these electrons through the tunnels. So I was able to do the design model. So we set the carbon nanotubes as the source gate, which will allow us to have high carrier mobility, low power consumption, and even excellent scalability. So we can shrink them as much as we can. So the designs went to different phases. The model itself, we tested the device settings, the interior and exterior device settings, also the environmental settings that helped us to mimic the real-world transistor applications. So different of results we had. So the carbon nanotube itself allowed us to apply until 1 nanoampere of current. So with this carbon nanotubes, we can take one step forward than the silicon transistors and enter the new electronics conductors. Thank you very much.